Hello and welcome back. This is Jonathan Gardner. This is part of my Theory of Python video series where I cover the Python language in detail and I talk about the concepts in computer science as well as software engineering as a practical career. This video, I wanted to cover programming languages as a general concept, what programming languages are, how they work, and things like that. The history of programming languages. So a long time ago, people would actually program directly. They would encode a sequence of bytes that represent the instructions they wanted the CPU to run, and they would put that into some form of memory, maybe a punch card, maybe a tape. Maybe they just program the front of the computer with toggles, and then they'd run the program directly. And this is obviously very difficult. Nobody that I know of does this anymore except on the simplest of devices. So people started abstracting out the programming languages. They decided that rather than writing in pure numbers or even pure binary, they'd like to have symbols that represent things. And so there's two languages that developed. One is the ALGOL family of languages. And this tree basically gave us languages like C and C++, Java, and it also gave us languages like .NET, C#, and also Python. Python is an ALGOL-based language. Fortran as well. Fortran is an old language. COBOL, I think, is also an ALGOL language. I don't remember. I forget what COBOL looks like. I remember studying it a while back. Anyway, ALGOL is a family of languages, and the hallmarks of ALGOL is it's basically like anything you'd find in a recipe book where it says do this and then do that and then do this and then do that. Okay, very basic programming language style. It works. It's easy to understand how it translates to the machine code. It's easy to analyze programs, but it's hard to write programs in ALGOL. And this other language called Lisp appeared in the 50s. And Lisp is what I'd call a functional programming language. And I mean functional not as in it actually works, but it's the central concept of Lisp is the function itself, right? We'll talk a lot in detail about what a function is in Python, what that means in programming languages, and why it's different than a mathematical function. So in Lisp, what they did is they figured out that if they could write a single function in the machine code, or rather in one of these languages, then they can write programs that look nothing like ALGOL, right? A very high-level language where the program itself is a data structure that can be analyzed and modified. Very, very useful. A lot of the ideas that Lisp introduced have been transmitted to these other languages. So when you study like if, while, loops and stuff like that, that's all Lisp. When you see us passing functions around in Python, that's all Lisp as well. We're not going to cover Lisp in detail of any way, shape, or form. I'm definitely not a Lisp expert. I did try some Lisp programming way back when. I enjoyed it immensely. It was a lot of fun. All right, so let's talk about what makes up a language. So if you wanted to learn a language, you have to learn the components that make up a language. So one of the most important components is the syntax. And the syntax is basically the rules for what text is acceptable as the language. Okay, and if you see a syntax error, that means that you wrote something that does not comport with the language. Okay. Syntax just describes how you describe the code. The other thing that we need to think about the language does is how it is compiled from the text that you write to the actual program that runs on the CPU. And there's a number of different ways that this is handled. The compiler often has a ton of optimizations, and people brag that a language is fast because the compiler is fast. This is mostly nonsense. Okay, so if people say my language is fast, you can just kind of make a funny look at them and say, shouldn't your compiler make up for all the work that you do there? Your job as a programmer is to choose good algorithms. The job of the language is to compile those algorithms to a very efficient form that runs on the computer well. Okay. Nowadays, we don't actually compile down to actual code that runs on a CPU, but we worry a lot about VMs, virtual machines. Java, Python, C# all use virtual machines. It's a very common pattern that we see in languages, modern languages. And with the VM, you can actually get something called the JIT compiler. What the JIT compiler says just in time. Okay, and what this does is it says if you run a piece of code, you're going to run an optimization pass on that piece of code to make it basically machine native. So like if you're running on a Windows computer with an Intel chipset, then you run the just-in-time compiler on a piece of code that you run and compile it down to instructions that run exactly on that platform with the exact instructions that that chip needs. And so the next time you run that, you can just run that raw code, so it's a lot faster. JavaScript was one of the first languages to really expose how important JIT is. Java's been doing it for a while. Python doesn't do JIT compiling, but PyPy, which is an alternative implementation of Python, does. We'll talk more about PyPy later. The other thing that we have to think is the type system. And this gets into the data structure. How do you organize the data in the program? At a most basic level, most assembly languages, they just say everything's memory, everything's a byte. But other languages say, well, that byte is an integer, and that byte is a floating point, and that byte is a string. And then you get things like Python, where everything in memory has tagged with it the type that it is, and instructions on how to decode or encode that type. There are many different kinds of type systems, and people try to boil this down to like there is this type of programming, this is this type of type system. It's nonsense. There's many vectors. One of the most important aspects is dynamic versus static. In a dynamic type system, the variables that you use in the program can refer to any type of variable, any type of value. We'll talk a lot about variables. I'm going to build a special video just on variables. We're going to talk about namespaces and everything like that. In static type systems, the variable name has associated with it the type of the object you're looking at, right? So in C, for instance, you have to declare that this variable is an integer. And so whenever you access that value through that variable, it knows it's an integer. In Python, you do not declare that it's an integer. You just say this variable points to that object, and the object itself knows what type it is. Okay. Static variables. Okay. And typically with static variables, the reason why people like these is it's pretty simple to write a compiler that can go directly to the CPU that's very fast. Dynamic, you have to keep checking the type of the variable, the type of the value of the variable, which can be slow, but there's also optimizations where once you know that something is a particular type, you can do something. There's a thing called Cython. It's another alternative implemented Python. Also PyPy also does some optimizations for this, so it's not a huge deal. In the early days, it was a big deal. Now it's not such a big deal anymore. The other thing we have is strong versus weak. In a strongly typed system, every value knows exactly what type it is. And so you can look at any region of memory that's being referenced by a variable and say, what are you? And it'll tell you, okay? In a weak system, nobody knows what they are, right? And so you go to a region of memory and say, what are you? And it says, I'm just a mush of bytes. I don't know what I am, okay? Typically, you have static weak or dynamic strong, but I've seen hybrids that do combinations of the above. Java, for instance, is one that does a hybrid approach. Okay. Another thing to think about with languages, let me scroll this up here a little bit, is whether it's functional. If you can pass around functions and operate on functions, there is a tremendous amount of power that comes with that. And so nowadays, if a language isn't functional, if it doesn't have that parameters, those properties, I'm going to say, I don't know if I want to learn that language. I don't know if I want to use it, and I'll be able to expose fairly rapidly algorithms that the language can't handle very well because it's not functional. Another thing to think about is object-oriented. This is all have to do with the type system. Object-oriented languages tend to have a system for defining new types, and there's a million different ways to do this, and everybody argues with each other what truly object-oriented is and what's not. I think it's a pointless argument. We just look at each system in isolation from each other, and then we learn that there is some comparisons and some things are not comparable. And there's another style, there's like some programming styles that you might see. Like there might be parallel, it allows parallel programming, or it allows reactive. I don't know the right word for this, but in JavaScript, you're basically specifying a bunch of callbacks. And so your code doesn't like ever run in parallel with itself. And you're responding to anything that's happening to the user, which works. It's great, okay? Another thing to think about a language, and this is kind of tangential, it's not really part of the language as we think about it, but the popularity of the language is an important factor. If a language is popular, it's fairly easy to find programmers, it's fairly easy to get help, it's fairly easy to find tutorials and documentation and things like that. There, you have to be careful because some languages kind of fake their popularity with a marketing department, Java. And so if there is a marketing department that's being paid to hawk the language and make it seem more important than it really is, you kind of have to take messages from the marketing department with a grain of salt. Most languages don't have a marketing department. They just have a team of fans that are very interested in the language, having fun with it. Python itself kind of started off as a joke, and then it became useful, and people recognized its value, and so it basically advertised itself by word of mouth. And that's the kind of language you want to see. Other things that affect popularity is you might have free languages, free programs versus free software. Free software is not necessarily free. This free software, we're talking about the GPL. Free means $0, right? And just because it's $0 doesn't mean it's free as in beer, but not free as in freedom. So free software is free as in freedom. You're able to do things with it. This is important. There's also open source. Open source says that you can see the source, you can may be able to modify it, maybe not, okay? And then we have closed source as well. Closed source is you're not allowed to look inside the box, okay? So there's a whole gamut in terms of licensing and how software gets distributed. I'll probably make a video about this, although there's been several videos made about that topic. Purpose. Something else to think about is why this language exists, what it's for. And some languages exist for very specific reasons. Let me give you an example. SQL, one of my favorite programming languages. It's great if you want to interact with a database. It's a terrible language otherwise. Okay, so you have to think about the purposes. There's, for instance, let's say that my program is going to use coroutines. That's a key feature of it, in which case Python is probably not right for you. There's other languages out there that are very good. Erlang is very good at coroutines. So if you want to use the actor model, Python is probably not the right approach. There's a discussion that people might say low level versus high level. And what this is talking about is how far away from the actual CPU code you are in the language. And this, to me, is kind of a meaningless thing nowadays because compilers are so advanced that even low-level languages are very, very far away from the actual compiled code. And I challenge anyone that writes C code to actually go in and look at the compiled code and figure out what in the world is going on. So high-level typically refers to languages like Perl and Python where you're programming on top of a VM with a very advanced language that it would be very difficult for any average programmer to see how to convert to machine instructions. Okay, so programming languages are important. It's important you choose the right programming language for the job. If you don't know what language that is, the answer is typically it's going to be Python for most jobs. There are some cases where I would not recommend Python. There is a huge difference that I found between Java and Python in my experience. I estimate that I was basically about 10 times as fast with Python than Java. I can do 10 times as much work in Python than in Java. There's actually, one of the jobs I had was working on maintaining the Perl website of a popular website at the time while they transitioned all the developers to Java. And me, by my lonesome self, I think there was one other developer, we were able to outcode like 30 developers just using Perl versus Java. And it was a problem because the company, the product managers, they wanted to develop their features and push them out. And so they ended up saying, why are we doing Java again? So, because it was such a huge cost. Okay, my recommendations. First of all, your goal as a developer, as an engineer, is to learn as many languages as you can. I have never met a developer that knew too many languages, okay? By learning other languages, you get better at your own language, okay? The other thing that I recommend is if you're gonna learn programming languages, I would start with Python, kind of as a foundation to build on. The second language you're gonna learn is probably Bash, which is the shell scripting language on Linux. Most of the software you run is gonna run on Linux, unless you're writing video games. Okay. After that, you're going to be like most people and you're going to want to build a website. So you're going to learn SQL and you're going to learn JavaScript. JavaScript is a fairly quirky, it's a pretty cool language actually nowadays. They've made some really good decisions. At some point, you're going to have to learn C++ or C, probably along with that, maybe some Java. Okay, this is very good to get that experience exposed to those two languages. I'm going to say, please go learn a Lisp-like language. I would include Lisp, Scheme, even Haskell. Haskell is kind of like a more modern Lisp, but Lisp itself is a dinosaur, but it's awesome. And then I would say go crazy and learn something like Prolog. Okay, some crazy language that will really expand your mind on what languages can do. So Python, why Python? It's simple, it's easy, you can master the language rather readily, and also it allows lots of flexibility, so you'll be able to learn and explore lots of different concepts. That's why I'm starting this video series on the theory of Python and not the theory of Prolog, right? Although Prolog would be very interesting. So would Lisp. I don't know Lisp as well as I should, but it's very powerful. Anyway, guys, thanks for that. If you enjoyed this, if you have questions, please leave a comment below. Let me know if there's anything I can do to make these videos better. Take care and bye-bye. This video is part of a series on the theory of Python. You can click on the left to see the playlist and on the right to support my channel. Thank you very much for your time.